Hello, welcome to section 8.4. What we're going to do is talk about standard deviation. So what that means is it's going to be kind of like how interquartile range is related to a median of a data set. Standard deviation is going to be really related to how the mean was calculated. So what we're going to do is work through a couple examples where the calculator is going to do the calculation for or of the standard deviation for us. We'll talk about what that means by the spread of the data. We'll take a look at a dot plot, how we can use a dot plot to calculate the mean, median, standard deviation, and IQR. And then we'll just take a look at two data sets and be able to compare them without actually calculating any of those four values. So in this first problem, I have 10 numbers on a data set. We're going to calculate these four things, and then we'll just talk about them a little bit and what they mean in context. So I want you to imagine like these are a bunch of test scores. So somebody scored very, very low at a 45, and then we got a bunch of numbers in the 70s going all the way up to a 91, which would be considered like a B plus or A minus, whatever that is. If we talk about like a class average, you want to have an idea of where everybody in the class kind of is as far as their ability. So what that 45 is going to do to your class average is bring it down, but let's see why that is. So we're going to use standard deviation to talk about that and how it does drag down that mean value. So I'm going to enter in my data in for L1, have my 10 data points in there. I'm going to go to stat, we're going to go over to calculate, and calculate the one variable statistics. So what you can see is that I have a mean of 80.1, so that's the top number, indicates what your calculated class average is. So that's an 80.1, and if you look down to about here, this little symbol represents your standard deviation of your data set, and what we're going to do is round to 2 decimal spots, so 12.72. And then what I'm going to get from down here is the median value, which is an 83, which represents the middle of all of these data points. So the median is the part that I don't care how low the lowest value is or how high the highest value is. The middle's the middle. So that's what the median represents. And then I'm also going to take down Q1 and Q3, so that'll help us determine what the interquartile range is of our data. So what I'm going to do is copy these 5 or however many numbers it is down. I have my mean was 80.1. I had a standard deviation, which was 12.72. And then over here we'll say that our median was 83. And then I'm going to calculate the IQR right away by taking Q3 minus Q1. So in order to do that, I'm going to take 88 minus 77. Which means that my interquartile range is 11. So we would say that the X bar right here, your mean value, would be the calculated average, and 12.72 is the standard deviation, which means on average, each data point on average is 12.72 units away from the mean value. For median, that would be, if you made the box and whisker plot, your median value would be what's in the middle of the interquartile range here. So your median would be somewhere here, and then again the interquartile range would be from this 88 minus the 77, which indicates that there's 11 units on the inside. So let's kind of talk about this for a second here. If I were to say what would be the better measure of central tendency, when we say measure of central tendency, you're talking about either the mean or you are talking about the median. So which one of these would you say would characterize the data a lot better than the other one? And I'm leaning towards the 83 because if you take a look at all of these values, the majority of them are pretty good test scores. I would say if you were just to look at these values, not looking at the 45, but if you're looking at the rest of these data values, it looks like your average would be somewhere around the mid-80s. But if the 45 is in there, the 45 is definitely going to affect your mean, because when you add up all your data values and you divide by the 10 values that there are, this 45 is going to drag your mean lower than the median is. So what that means, and I'm going to summarize this down here, when data is skewed. So in this case, our data would be skewed left because of that value of 45. So when data is skewed, use median as measure of central tendency. This is really ugly writing, but and IQR to measure spread. So the IQR is going to measure the spread if we're using the median as our measure of central tendency. If your data were symmetric, so if the data is skewed, like I said, we're using this median, we're using IQR. If your data were symmetric, which means, let's say we didn't have this person scoring a 45 on there, and all of a sudden you had some data that was really close together, and it was a really nice bell-shaped curve where your mean is where the most people performed, and you had some people on the low end, some people on the high end. Well, if your data were symmetric, then you would want to use mean for the central tendency, and you would use the standard deviation for your spread of your data then. So standard deviation is associated with mean, and IQR is associated with median. So the next problem we're going to do is looking at a dot plot. What I'm going to do is enter this data into the calculator. We're going to calculate the mean, we'll calculate median, IQR, and standard deviation. And I want you to take a look right away at the fact that our data looks like it is symmetric. So going with that concept that I just said a second ago, when your data is symmetric, the measure of central tendency that's going to better summarize your data is going to be the mean. And that means we would use the standard deviation with that. So let's calculate that. Right now, again, we're going to go to Stat, we're going to go to Edit, and I'll start entering these values in. So I have a data point at 40, I have a point at 41, I have 3 data values here at 42, so I'm going to have to enter that 3 times. I have 4 of them at 43, I have 1 point at 44, 2 of them at 45, I'll scroll this over, and then I have 1 data point at 46. So you have a couple values on the low end, couple values on the high end, but you have this peak, a big cluster of data around this middle point, and that's what's making our data symmetric. So we would imagine that our mean would be somewhere close to this peak here of our data. I'm going to go to Stat, we're going to go over to Calculate, and calculate our one variable statistics, and I'll copy these down. So my mean is 43. I have a standard deviation of 1.62, which is a very low number. And again, the reason why that average distance is so low is because you have a big peak of data here. You have a lot of data points that are very close to where this mean would be. So if my mean is 43, it's right here where the spike is. It means your average distance that points are away from the mean is 1.62. So a bunch of your data is basically somewhere in this range right here. And that's a really good bell-shaped curve, and it means your data is very symmetric. I'll copy down what the median is and my Q1 and Q3. So I have 42, 43, and 44.5. So 42, 43, and 44.5. And that represents my first quartile, my median value, and Q3. So your mean and your median both came out to the same number. That's all right. It just indicates, again, that peak of your data. The middle of your data is there. If I calculate IQR, you would take Q3 minus Q1. So 44.5 minus 42 is going to mean that I have an interquartile range of 2.5. So again, the IQR is associated with the median, which would, again, we would kind of summarize all that data using a box and whisker plot, which means that your median, the 43, would be somewhere in the middle. And again, you have 2.5 units separating your quartile 1 from quartile 3. But again, if I say which measure of central tendency would you use to better summarize the data, you would say since the data is symmetric, we will use the mean. So we will use mean for central tendency, or measure of central tendency, which basically again means kind of where that average of your data is, where a big chunk of your data lies. So we're going to use the mean for the measure of central tendency and median, or I'm sorry, not median, we'll use standard deviation for the spread of the data. So again, the reason why we are using the mean when our data is symmetric is because these points, even though one is low and one is high, they're not going to be outliers. And what the outlier is going to do, like it did in that first example, if we think about these numbers like they were test scores, the 45 is going to take your calculated average and it's going to really bring it down. If we were to have a really high test score, somebody that got extra credit or something like that, what that would do is make your data go, or it would make your mean go a lot more to the right, and it would increase your average. So if we don't have those outliers, it's not going to affect our mean then. And that's why if your data is symmetric, if you don't have those outliers, you would want to use the mean. So last problem then, we're going to take a look at which data set we would expect to have a higher standard deviation based off of just looking at these two data sets. So as you can see in this first one here, I have a big peak in the middle. My data is clustered together. So I'm going to write that here. It is clustered. You have a peak in the middle, which could be where your mean or your median would lie. On the other problem, though, you have this small peak in the middle, but notice that your data is more spread out. So if your data is clustered, again, I want to associate standard deviation to where your mean is. I want you to imagine my mean is going to be right down the middle in both of these cases. So I'm going to label that as X bar for the mean, but I want you to look at how far these data points are away from my mean. So 38 is very close to my mean, 43 is very close to my mean, and everything in between there is even closer. So since your data is clustered, you would have a small standard deviation. Over here, 33 is a lot farther away from my mean. 47 is very far away from my mean. So what these numbers are going to do is increase your standard deviation, which means that that distance away that these numbers are from your mean is a lot greater than the ones on the first data set. So what we would expect then, and I'm just actually going to type this down here, we would expect data set 1 to have a lower standard deviation since the data is clustered around the mean. Data set, I'll capitalize this, I'll be nice. Data set 2 would have a higher standard deviation since the low and high values are further apart from the mean. And again, that average distance would increase then because these numbers are farther away. So just to prove it then, I actually did calculate these values. My mean for data set 1 came out to 40 with a standard deviation and average distance of 1.41. And then for data set 2, even though these values were a lot more spread out, my mean also came out to a value of 40, and my standard deviation came out to 4.73. So what that means again is that this average distance is significantly higher than this one was. So let's say I'm a teacher and I'm going to give a test to a class and I want my students to perform pretty similar to each other. I don't want their scores really spread out. What that would mean is that I would want a lower standard deviation. So I would want my students to perform like this, which means that nobody scored very low, nobody scored very high. It means that everybody is clustered together. Versus if I had something like this, it means that my data is really spread out. You might have a nice class average in the middle of that, but you have a lot of people performing low, you have a lot of people performing high, and that means that your class ability is kind of all over the place. So if your data, again, even though both of these data sets I would consider as being symmetric, since data set 1 has this cluster, I would assume that the standard deviation would be lower. So again, just to recap this, standard deviation is the measure of central tendency that we are associating with mean. IQR, the interquartile range, is your measure, or I'm sorry, it is your measure of spread, not your central tendency, is your measure of spread for the median.